Ready, Jan? Got a game today? Good. Jan, what's number 1 asking me to find? I'm probably going to give you 2 work questions, maybe only 1. If I only give you 1, it will be how much work to put something in orbit. And I do see the word orbit. I do see circular orbit. So I can't use force times distance. Work is going to be the change in potential plus the change in kinetic. When can I completely cross out the kinetic energy? If it asks how much work to lift something up, but not put it in orbit. Or if it asks how much energy just to get it to a certain altitude and then let it go and drop back down. Because if you're in an orbit, what keeps you in orbit is your kinetic energy, your orbital speed, V orb, which was gravity that's pulling me in a circle. I think V orb was the square root of big G, big M over R, but don't quote me on that. I need to derive it. So the fact that we're in orbit, I got both of these. I usually solve these separately. I'm going to find the change in potential energy first, which is going to be negative big G, big M, little m over R. Final minus initial. I'm going to have a minus minus, which is a plus, okay? On my next line, PE, it's going to be negative big G. Ooh, we're around the moon. I almost started to go 5.98. No, don't know. What's the mass of the moon? It's 7 point something, I think. Isn't it? 7.35 times 10 to the? Little m does not cancel here because there's not a little m here. So 1600. And then I need to figure out, did they give me did they give me a radius from the center of the planet, or do I need to add the radius of the moon? You know what? Above the surface of the moon, they've given me that distance there. I need to add the radius of the moon to it. So underneath this fraction, it's going to be 2 times 10 to the 6th. Oh, in the homework, there were times I gave you distances in kilometers, and I did that because that's what you'll hear on the news or in industry. On your test, I'm not going to try and catch you, Quinn, with a sneaky unit. It'll be in meters. But I do need to add the radius of the moon. What's the radius of the moon? I don't know this one. 1.74 times 10 to the 6th. Oh, got to pause for a second. I don't know what that is there. Get rid of that. Come on. Come on. My eraser not working? Let's start writing some more. Minus is a plus. There we go. And this is why I started doing ditto marks, because same thing times same thing times same thing. What's our initial? 1.74 times 10 to the 6th. Okay. Am I wrong? Oh, I thought I'd missed something. I got interrupted for a second there. Someone showed up late, wrecked my train of thought. I'm going to very, 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 very carefully type this in. And I don't have a clever trick, Madison, to help you figure out how to type these in without making a typo, except just to say, be really meticulous. By the way, this unit, this is why I yelled at you in Physics 11 about getting a good calculator. Because trying to do this on a basic one that didn't have arrow keys and the ability to backspace, it's just, you're going to make a typo almost every time. So, negative 6.67 times 10 to the negative 11. Mass of the moon, 7.35 times 10 to the 22 times 1600 divided by bracket 2 times 10 to the 6th plus 1.74 times 10 to the 6th. For the first term, did you all get negative 20973? I'm going to go negative 2.0973 because there's a 0 right there. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got a little nervous because typically they were in the 10 to the 10th. Are we around the Earth or the Moon? less energy required. So the 10 to the 9th, that's probably right. Negative 2.0973 times 10 to the 9th joules plus. And the nice thing is, because I have a good calculator, I can just backspace, change that. Did you get oh, I don't need the negative, Mr. Duick. So here, I'll fix that, times by negative 1. Now it's positive. 4.508 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? 4.508. So the change in potential energy is negative 2.0973 scientific notation button 9 plus, answer button. And I get the changed potential 2.4107, 2.4107 times 10 to the 9th joules. I'll draw a box around that because I need that. Am I done? Now I got to do change in kinetic. Nick, what's change in anything? You'll get it right one of these times, and then we'll have that little giddy thrill of success. Yeah, it's going to be a half mv final squared minus a half mv initial squared. Kinetic energy hasn't changed. We don't have we could create a cosmic version of kinetic energy by maybe plugging in v orb right there, but it's still a half mv squared. But Maddie, where do we say we're launching from? Now, we're on the moon, so I don't know my Marvel or DC. Who has a base on the moon? Because on the Earth, it was Superman's Fortress of Sol. It was the North Pole, and the moon does have a North Pole as well. So we're assuming that we can do that. So it's going to be 0.5 times 1600. Did they tell me the speed? What if they hadn't told me the speed? Gravity is what's pulling me in a circle, and I can solve for V orb. I think I gave you one of those in another question. But for now, they did tell me the speed. And the reason it's so specific is I calculated the speed. 1.145 times 10 to the third. By the way, 1.145 times 10 to the third, that's just 1145. It's less work to not write it in scientific notation, so I did that. Don't forget the squared. And I got 1.0488 times 10 to the 9th. I choose not to ask. We're good? We're sure? No one noticed. Don't worry. Okay. Mr. Dewick, that makes it worse. Yeah, I know. That's what makes it fun. Oh, I'm sorry. 2.4107 times 10 to the 9th plus 1.0488 times 10 to the 9th. And I can't remember again during a flex block, I hate rocket science. It's rocket science. I can't make it easy. I do find the physics of it really neat, and I like how it all fits together. But yeah, Clody, it's a fat ton of typing. Okay? 2.4107 scientific notation button 9 plus, at least I can go answer button. Oh, is the final answer 3.46 times 10 to the 9th? Whew. Seeing a lot of people, by the way, writing like mad as though they haven't done the quiz. A better option would be to try the quiz tonight and just watch. You know who you are. If you got that, 7 out of 7. Okay? Otherwise, 1, 2, 3, 4, 5. I would probably go something like this. I would probably give you 1 mark if I saw that, because you've recognized that we can't use force times distance, and that's worth something to me. I would probably give a half mark if I saw that number, a half mark if I saw that number, 1 mark for that. So by finding the change in potential, you get 3 out of 7. Then I would probably give you 1 mark for that, 1 mark for that. I would probably give you 1 mark for that. That's 6 marks. You know what I can give up? I would probably give 1 mark if I saw that you had used that and not MGH, because again, that requires some knowledge of physics. But if you got it right, 7 out of 7. Oh, Mr. Dewick, number 2 is the same question, but worse. Why is number 2 worse? I didn't give you the orbital speed. Here we go. Sarah, what are they asking me to find? How much? In fact, you know what? Copy. It's going to be the same old for starters. Okay. Now I'll have to use numbers from the Earth. So the change in potential energy is going to be negative big G. We did say we'd use the mass of the Earth enough that I was okay with you putting capital M, lowercase e, 3,200 all over. This is a radius. Do I need to add the 6.38 times 10 to the 6th? Nope, I already did that for you when I found that number. So it's just going to be 8.3 times 10 to the 7th, plus same thing times same thing times same thing, divided by 6.38 times 10 to the 6th. Negative 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24th times 3,200 divided by 8.3, scientific notation button 7. Did I make a typo? Don't think so. For the first term, did you get negative 1.5378 times 10 to the 10th? People nodding? Because I make typos on this too. Negative, what did I say? 1.5378. 1.5378 times 10 to the 10th. Plus, backspace, delete the negative, and just change the bottom to 6.38 times 10 to the 6th. Oh, 2 3 zeros and a 6 times 10 to the 11th. 1, 2, 3. So, the change in potential energy is going to be negative 1.5378 times 10 to the 10th plus, answer button. And I get 1.8468 times 10 to the 11th. 1.846. Am I wrong? Is that right? People nodding? Joules, and I'll draw a box around that and come back to it later. That's how much energy just to get it up there. That won't keep it up there. We now need to give it kinetic energy. You're on. Nick, what's changing anything? Finest minus, you'll get there. It's going to be a half mv final square. It's tough. It's strangely tough to say. Why do you think I ask you guys to say it? You'll notice I rarely say it myself because I botch it so often. Maddie, where are we launching from on the Earth? Santa's workshop or Superman's Fortress of Solitude? Problem. I don't know that. And by the way, this VF is really the orb. You may have memorized V orb, and if you have, again, Cohen, that's okay. But I'm going to quickly rederive it by saying gravity is what's pulling me in a circle. Actually, I'm going to go like this. Big G, big M, little m over R squared equals mv squared over R. And I'm going to be a little bit clever here. The m's cancel. Little m's cancel. One of the r's cancels. What do I have by itself here, Keegan? V what? You know what? it's a v squared here. I'm not going to bother square rooting and then squaring. I'm going to replace this v squared with big G, big M over R. Why not? So this is where I'm going to save myself a line of writing. I'm going to say, okay, apparently kinetic energy is a half little m, big G, big M over R. I can go back several lines, and so if you can go back several lines on your calculator, here's a good trick. Right there, I've got big G, big M, little m, and R sitting right there. I can save myself a fat ton of typing. Ooh, no, R is going to be orbital, the final one, which is 8.3 times 10 to the 7th. Delete that one. And 0.5 in front. I could multiply by 0.5 after, but that would scare you. 1/2, where's little m? There it is. Big G, big M over R final. Our kinetic energy up there. Now, as you get further from the Earth, do you have to go faster or slower to stay in orbit? Slower, gravity is weaker. So we're really far from the Earth. I think my orbital speed is going to be on the smallish side. Oh, this is kinetic energy, though, so I didn't bother calculating orbital speed. 7.688. You know what? I guess 7.689 times 10 to the 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 7.689. 7.689 times 10 to the 9th. There is my change in, let me make sure I counted that correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. We don't need as much kinetic energy to stay up there, but the trade-off is way more potential energy. So it's not like you're coming out ahead to put satellites further away from the Earth. It uses way more fuel to put stuff further out from Earth. Plus 1.8468, scientific notation, 11, I don't know. Did people get 1.92 times 10 to the 11th? People nodding? Okay. Joules. Whew! If you got that, 7 out of 7. Otherwise, I'd probably give you, have to break this down a little bit more. I'd probably give you a half mark if I saw that. I'd give you a half mark for that, a half mark for that, a half mark for that. What are we at? 2, we're at 3. I would probably give you half mark if I saw that, half mark if you found the orb, half mark for that. What are we at now? 1, 2, 3, 4, 4.5. I don't know. 5.5. I haven't given enough marks up, Mr. Duick. Where else would I give up part marks? 1, 2, 3, 4, 5. You know what? I'd probably just give you 1 if I saw that, and 0.5 if I don't know. Now, I wouldn't give you any of that. I will not give you a question on the test where I ask you how much work and I don't give you the orbital speed. So as far as I'm concerned, this one is totally fair game if I give you the orbital speed. But I'm going to ask you to find an orbital speed in a separate question. I guarantee it. So this one here I did on a quiz. I won't ask you one with this much work on a test. Number 3. Planet Duick. Oh, what a great planet. Mass of pi, radius of E. That's a good planet. What's its escape velocity? Some of you may have memorized the escape velocity equation. If you have, that's fine. I have no problem. I'm going to derive it for those of you that haven't, and because I just think it's good practice. How did we find escape velocity? It started out with kinetic energy. but we had this weird potential energy, conservation of energy equation. What did we want our final potential energy to be out at the edge of the universe? Because we defined it that way. And we wanted to do this so perfectly that as we shut off our engines and coasted and coasted and coasted, slowing down, slowing down, slowing down, we would exactly come to a stop right when we reach the edge of the universe. In real terms, it's once you're sufficiently far enough away from the planet that the gravity field is negligible. So we had this strange idea of a half mv initial squared plus negative big G, big M, little m over R initial equals 0. We have a half M, and this V initial is really V escape squared equals big G, big M, little m over R initial, plussing it over. Is escape velocity for the Starship Enterprise or the Space Shuttle or a tiny cube satellite the same? Yep. So what did we find? Escape velocity was equal to 2 big G, big M over R initial. And that R initial, you can be starting anywhere from the Earth. In this case, I think we're starting on planet Duick's surface. Some predictions. I don't know if anybody remember what the escape velocity of the Earth was? We calculated it. It's almost exactly 11,100. It's almost 111,000 meters per second. It's 11,000, I think, 180 meters per second or something like this. What's the mass of the Earth? What's the mass of planet Duick? Larger? I suspect escape velocity here is going to be bigger than Earth's because I have a massive ego, and so of course my planet has to be bigger and better than Earth. Right? You're not surprised, Madison. Madison, I know you were away, but I've scrolled down. What was the mass of planet Duick? 3.14 times 10 to the what? Sorry? 30? And what was the radius of planet Duick? 2.72 times 10 to the? Okay. 2 times 6.67 times 10 to the negative 11 times 3.14 times 10 to the 30th, divided by 2.72 times 10 to the 7th. Oh, you're doing the food. Thank you. Square root answer button. Thank you, thank you, thank you. Yeah, you can go right out that door if you want, kiddo. Did you get 3924264? Is that right? Yes? 3. It's called an attention span, people. By the way, never mind, they'll bring it back and they'll put it through that door. No problem. 3.92 times 10 to the 1, 2, 3, 4, 5, 6. Probably because if you haven't figured out, I'm also fascinated by black holes. I think they're a cool space concept. I'll probably have you find the gravitational field strength near a black hole, and I'll probably have you find the escape velocity from a black hole. We won't be inside the event horizon, so the escape... Thank you, kiddo. Can you shut the door behind you? Thank you. The escape velocity won't be bigger than light, but... if you're wondering a future question on the test, I'll probably give you a black hole question. Okay? If you got that, 7 out of 7. Otherwise, I would probably go 1, 2, 3, 4, 5, 6. And I'd probably give you 7 marks the extra mark if I saw that you'd realize it was equal to 0. Again, if you jump straight to that because you've memorized it, then I would say, oh, you've got 5 out of 7 because that's how much derivation to get there. Okay? Is that okay, Cohen? You're counting up your marks? Okay. This last one? I am going to ask you to do a cosmic conservation of energy. The key is do not try and get the thing by itself. Instead, we're going to crunch numbers, turn it into one number, then get whatever we're trying to get by itself. So, what's this asking me to find, Mallory? Fast. You know what? I think there's a change in height, change in speed, yucky curvy force. This is conservation of energy. G. It's going to be KE initial. Were you echoing me there, Keegan? That's all good. Are any of these zero? Now, we got to be careful. A lot of people want to say, well, isn't potential energy final zero on the ground? Not cosmically. Where have we defined zero out at infinity? If it had said from a very long distance away, then I could assume potential initial was zero. That's them saying we're starting out at infinity. But I don't think any of those are zero. What about kinetic? Nothing's zero. Okay. I agree, Sarah. A stink eye is warranted. Other things to notice. We're used to our final being in space and our initial being on the surface of the Earth. Here the roles are reversed. We're starting in space and crashing into the Earth. So I'll make sure this is where I put the further out radius. This is where I'm going to put the closer radius. What are they asking me to find? They're asking me to find that. I'm going to plus this to this side. Oh. Do the little m's cancel? I will. You don't have to, but I will. So I'm going to get 0.5 V initial squared minus big G, big M over R initial plus big G, big M over R final. That equals V squared, V final squared over 2, or 0.5 V final squared. I don't care which one you want to do. I am going to turn this into a number. First, I'm going to substitute the numbers in because this is a lot of typing. So we're going to have 0.5. I've scrolled down. What was the initial velocity or speed?
1.37 times 10 to the 4th.
That's traveling pretty fast. Don't forget the squared. Minus big G. Are we Earth? Mass Earth divided by, where are we starting out in outer space? They did give this as a radius because it's from the center of the Earth, so I don't need to add the 6.38. So 2.2 times 10 to the 7th. And then plus, same thing times same thing divided by 6.38 times 10 to the 6th. That equals a half V squared, F squared over 2. Whew. Okay. 0.5 times 1.37 to the 4th squared minus, hang on, Mr. Dewick. Let's do these one number at a time. So that first term works out to, you know what? I'll write out the whole thing. 93845, 3 zeros. 93845, 3 zeros. 93845, 3 zeros. And then I'm going to have 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24th divided by 2.2 times 10 to the 7th. I got a typo. 6 point, looks good, looks good, looks good. Do you get 1.813 times 10 to the 1, 2, 3, 4, 5, 6, 7? 1.813 times 10 to the 7th? Backspace. Edit. 6.38 times 10 to the 6th. 625, 181, 181, 625. 6.252 times 10 to the 1, 2, 3, 4, 5, 6, 7. 6.252 that equals V squared over 2. So it's going to be 93845 minus 1.813 scientific notation plus answer button. Whew. Making sure I haven't made a typo. Anybody else got a 1 point? Yeah, okay. 1.382 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 1.382 times 10 to the 8th. That equals v squared. Whew, over 2. Lena, how will I move the 2 over? And then I'm going to do that in one step because I'm sick of writing stuff. And I think you're all good enough that that's considered a fairly intermediate or basic step now, actually. Times 2, square root, answer button. Do you get an impact speed of 16,600 meters per second? Now, if I've made up good numbers, I do know that it should be faster than Earth's escape velocity because you're coming from out there with your own velocity and you'll gain all the energy that you would need to leave Earth coming back to the Earth. So 16,600. If you got that right, I would again give you 7 out of 7. Otherwise, probably 1 mark for that. 2, 3, 4. Half, 1. Something like that. Does that work? 1, 2, 3, 4, 5, 6, 7. Whew. Any lawyering with me? Now is the time. Okay. Pause for a second.